Hi there, I'm Geology Professor Shawn Willsey. These Cretaceous sedimentary rocks behind me expose dramatically what I think is one of the most fascinating chapters in the history, the geologic history of Western North America. So come with me and let's check out the clues and the evidence left behind by these rocks and see what we can piece together. So one of the first observations we might make here is that we have rocks, some of which make cliffs, some of which make slopes, and rocks of various colors. This gray unit out here is sort of a slope former. We can see that it's easily eroded. It's occupying much of this valley and this low area here. Up on the cliff band there, we see some lighter colored rocks that are much more resistant to weathering, that are forming the cliffs. And as we come back here just in front of us, we can see there's another unit that forms cliffs as well. Now all the rocks here are tilted down in this direction to the northeast, and so there is a bit of a regional dip. This slope in front of us is on the dip direction, so we can see the contact between these brown rocks I'm standing on and the bottom of these gray rocks spectacularly just below us here in the wash. So rather than just tell you right off the bat what these units are, I think it'd be more fun for us to explore them together. So I think what we might do first here is work our way down into this gully. Start here. These are going to be older rocks. Remember, everything's tilted down and to the right. And so if we start down here, that will be our oldest chapter of rocks we're going to see. And then we'll work our way up this ridge, look at the rocks exposed here along the ridge line, which is going to add another complex layer to our story, and then head down to these gray drab rocks below us here and see what they have to tell us about this event in Earth's history. Okay, so just working my way down off the ridge and down into this little ravine here where we have some other units exposed. Again, we want to work through the whole history. The Cretaceous is a particularly long period of Earth's history, coming right after the Jurassic period. And in Western North America, it was a time of dynamic changing in environments and climates. Tectonic changes were ushering in just a host of different environments. Of course, the dinosaurs were here at this time. So let's maybe start down here and then work our way up out of the gully. We don't have to go too far, because I think we'll see enough features in here to be able to piece things together a bit. So we can start maybe right here in this cliff wall here. And this tan unit, you probably guessed it, most common rock type, I suppose, or at least one of the most common rock types in southern Utah. Nice sandstone, just a nice, looks like it's a medium grained sandstone. Looks like there might be some cross bedding in it. You might see some little lines in here running counter to the regional bedding angles there. But then just below it, we have something a little bit different. In the recess of the base of this sandstone, we have this darker unit here, which is a little bit different. And if we come in here and grab some of this stuff, we can see it's particularly dark. It breaks into layers. Pick that piece up. Splits into layers a bit. It's incredibly brittle, shiny. Not at all like the sandstone. This is a very different unit. This is probably not a true high-grade form of this material, but this is all organic material. This is a bit of a coal sample we have here. So we can see the organic rich, carbon rich layers here in this piece of coal that's forming right at the base of the sand layer. Now the coal is a big clue because coal forms in swampy environments, in freshwater swamps, typically near the coastline. So the presence of this coal here is telling us that we had a swamp here in this part of Western North America during the Cretaceous, and then that quickly changed into a sand-dominated environment, perhaps a stream, maybe the floodplain of a river, maybe even a beach-type setting, but some sort of sand-rich environment. I'm going to work you up a little higher here If we look over here, we've gone up out of the ravine, working our way towards the ridge crest. Again, more sand layers right in front of us here. Then there's another dark layer, kind of hidden in the shadows there of this small overhang. And if we work our way into here, actually before we get here, on the ground in front of us, now who knows where this is coming from, it's out of place, but hopefully you can see how shiny some of this material is down here. Very reflective. It's essentially, looks like little pieces of glass, quite colorless. And if we take this and scratch it, try to scratch it with our fingernail, sure enough, it scratches pretty easily. These are just little pieces of gypsum. So these pieces of gypsum, again, it's out of place. It's just on the ground here. It could be weathering right out of the ground, or it could be coming down from something further above. But the presence of that gypsum would seem to indicate some sort of evaporative deposit, evaporation of water, probably seawater, possibly is causing the gypsum to be deposited or precipitated here. Let's check out this dark layer here. So if we come in here and look at this, this looks more like typical true coal that we might see in parts of Utah. So you can see how shiny this stuff is. Black, it's incredibly lightweight, breaks really easily, very brittle. So this again, some sort of swamp environment was the depositional setting for this coal. So we have coal just below us, then a sandy layer, we have the gypsum. Now we have a little bit more coal. But then as I look up the rest of the hill towards the ridge line, I don't see any more of that coal in any of the, on the slope here. So let's work our way up to the ridge line. And I think this next chapter will be the one that's possibly even more impressive. As we get up to the ridge line here, we'll be able to see what this hard unit is that caps the ridge, and hopefully be able to look at the clues that help us decipher its history. So here we are at the ridge line, and we have a nice resistant unit here. It's kind of gritty. This is definitely a sandstone, but here's what's most intriguing about it. What do you see? Look what's in it. The entire unit is just full of these gray, sort of rounded blobs. Let's see if we can find a good one that's fallen out and see if you can identify it. Here's some of them down here. Let's see, there's a couple over here. This is a pretty good one here. And if we look at the shape of this, these are fossils, these are shells, these are oysters, and it's full of it. The whole sandstone bed is completely composed of these shells, these oyster shells, just beds and beds of oysters. There's another one over here. Let me take you down to this one. Let's see if we can get that in the camera better. And zoom in a bit here. So you can see all of these shells just embedded in this sandstone. Pretty remarkable. And so, of course, in addition to just being wowed by just how many fossils we see here, the next question, of course, would be, well, what does this represent? What is the environment in which these were deposited? Look at all of them right here. Look at these shells, just awesome. These are all, some of these are golf ball size. I think I've seen a few that are almost fist size, just full of these oyster shells. So this obviously would be a marine setting. This would be and slightly offshore beach to slightly offshore setting in which these sands and all these oyster shells were deposited. So we've gone from the coal, which would be a little further inland or at a time when sea level was lower, because that coal deposits would be freshwater. Now we've got these clearly marine deposited sandstones. And so now we'll head down and look at this gray layer here and see what it can show us and tell us about the depositional environment at this point. This is all, again, part of the Cretaceous formation, or part of the formations from the Cretaceous period. Before we head down to look at the gray unit, I have to show you how big some of these oysters are. Here's one here in front of my fingers. Another one right here. And then moving up a bit, we got another big one here. One next to it, let me give it some scale. So here's a really large one here, and then one next to it, and then another oyster shell right here. Just so spectacular in this sandstone. This is all part of the Dakota formation. So this is a Cretaceous unit called the Dakota formation, and this is the very top layer, the top unit of the Dakota formation. And as we head down to the contact here with the gray unit, we'll look at that and we'll look and see, I'll provide the name for that unit there, and then we'll start to put this whole story together. Okay, so we've come down the ridge there. Again, this is all the ridge with the oyster-bearing, this is the oyster-bearing sandstone, part of the Dakota formation. And now we're down here looking right along the contact. You can see right through this little gully, this little swale here. This is the contact between the sandstone just below us and this drab gray material, this much softer material over here. We can still see right below us here some of the oysters in the sandstone. So you can still see some of these big, some of these are fist size, these really big ones right here, these large pieces of these oysters in the sandstone. Here's a whole bed of them right here. Again, sorry, these oysters are just cool. Like, I'm spending so much time looking at these shiny oyster surfaces that are basically like 90 million years old. But then we come down here into the shade, we can see that sharp contact. Again, I'm standing right on the sandstone with the oysters, this part of the Dakota formation. And then the next unit above us, right here, forms a cliff, but overall this is a very soft unit. And if we come over here and look at what's exposed in the cliff face here, it's interesting. It's gray, but we can also see some of this very cool kind of fibrous material, these little white needles. Again, these are pieces of gypsum. So this is an evaporite material. Here's me scratching a little piece right here. Let me zoom back out and figure out where I'm at. There we are. Scratch that little piece there and then show you kind of, yeah, where I scratched it. So this gypsum is evaporative material. The gray material, kind of blocky in here. Let's see if it fizzes a little bit with the acid. Yeah, sure enough, it's calcareous, it's calcite rich. This could be either limestone or perhaps, if it's sort of breaking into layers, might be a shale or a mudstone. So we can see some of this sort of blocky material here at the bottom. But as you move up and look at this stuff, yeah, definitely different, right? And there's no oysters in this, right? So literally I'm standing on material where there are oysters, and then we just come up, I mean, within a few inches or a foot, it's this gray unit, and I'm not seeing any of those fist-sized oysters here. So this would be indicative, this unit we're looking at would be indicative of sea level rising even higher. Remember, the oysters would be in a near shore, sandy environment, and now we've lost sand completely. The sand size component is gone Instead, we have much finer material dominated by calcite and some gypsum, and we've totally lost those oysters. So I don't know much about oysters, but that would either suggest that as the sea rose and inundated this area and no longer deposited sand because it was in deeper water, either the oysters migrated back closer to shore, to their kind of habitat, or maybe there was a big die-off of the oysters. Not sure about that, but kind of an interesting point. So the overall story here of this gray unit, I think we'll walk up onto the ridge here. So here's this gray unit. This is a Cretaceous unit known as the tropic shale. So even though it has a little bit of limestone here and there and some other parts to it, it's overall a very clay-rich shale. Oh, I picked a steep section to go up. And it represents what I think is one of the more fascinating periods in Earth history in Western North America. Let me get up here and then I'll try talking a little better. But you can see the popcorn texture of this material. Nothing's growing in it. This is from when this clay-rich material gets wet, it tends to swell. When it dries, it shrinks. Makes it very difficult for any plant to take root in it. Here we go. Now we're up a little higher. And so it forms this sort of badland type scenery. And then we can see in the distance, over there on the cliffs, some tan units that are forming cliffs. And those are more sandstones. So think about what we've come through here. We started over here on this ridge with coal and sandstone, and then that graded upwards into the oyster-rich sandstone that we saw that makes up most of this slope here. So that would be a near shore. That tells us that the seas were rising. And then we get into this tropic shale, which is in deeper water. So the sea rises even further. And then finally we see the sandstone, that's the Straight Cliffs Formation up there. And that's the sea dropping again. Now you'd think that this ocean would be coming in from the west. What these rocks record, this sea level rise, or what we call a transgression. But actually it came in from the east. This is a fascinating period of time known as the Cretaceous Western Interior Seaway. So this is the time when we had the ocean coming in from the north and inundating all of North America, connecting to the Gulf of Mexico in the south. And so this was a fascinating period where the mountain building event in Western North America was building up big mountains, but just to the east of it, we had what we call a foreland basin, an area where the crust was depressed slightly, that sagged down, and as sea level rose in the Cretaceous, the sea inundated that low area and formed a continuous seaway that was hundreds of miles wide, I think thousands of feet deep. Okay, so let's head up, walking through these ocean deposits here in what's now the deserts of southern Utah, through the tropic shale. Another little steep pitch here. Let me get to the top. There we go. Yeah, and then once you're on top of these things, you can sort of stay on the ridge crest. Here's more of this popcorn texture in this clay-rich material, showing where it shrinks and swells, along with pieces of gypsum that we find up here. Fascinating stuff. Well, here's a nice summary view that shows us the geologic history we've been figuring out here in this part of southern Utah. We can see the tilted beds of the Dakota Formation off to our west, forming the ridgeline just opposite us here with the road going up it, and then that transitioning into the gray tropic shale formation, which records the last sea level pulse here in the Cretaceous. This was the last time that the ocean touched this part of Western North America. Once this sea withdrew and we get to the Straight Cliffs Formation, the sandstones up there along the high plateau, then the sea was out of here for good. Then it was all terrestrial, land-based environments, pretty much all the way through to the modern times we see here in this part of southern Utah. Just a fascinating story and just a fantastic and beautiful landscape. Well, thanks again for joining me on this fun little excursion in southern Utah, going back in time into the Cretaceous to look at the fascinating history and some of the evidence for the Western Interior Seaway that existed at that time. Appreciate your support of the channel. If you want to make sure to like the video and subscribe, that'd be great. Also, there's links under the video description for ways you can support these geology education videos. Thanks so much. Take care.